Okay. Okay, cool. Hopefully I'm live now. Can people tell me like if it's still lagging? Okay. Uh, no lag, no lag. Nude says lag. No, no. I'll explain A again. Can people tell me like if it's still lagging or not? Video FPS lagging. Are you sure it is lagging? Lagging. There is lag. Lag. Okay. Okay. Now tell me, is it still lagging? It's much better. Better. No lag. No lag. Not lagging. Okay. Cool. Okay. Hopefully this won't lag anymore. Turn off now. Yeah. I don't think this will lag now. Okay. Let me just comment down the link. Okay. Okay. What is the link of? Okay. Okay. थोड़ा lag हो रहा है video. It's fine now. Okay. 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 Cool. Let's start. Let's not waste any more time. Okay. I'll explain problem A again. Let me just open Codeforces. Okay. Cool. Okay. Cool. Contest. Lagging. Is it really lagging? I don't really know like what to do. I can see it's lagging. Okay. Move my video. Is it better now? I don't think there is any difference. Okay. Okay, anyways, I'll start now. If it still lags, we'll see. Okay. Okay, so in problem A, what we had was okay, so in problem A, what we had was or n was equals to 7, r was equals to 4, b was equals to 3. Okay. Now, since we need 3 b's, okay, what we'll do is we'll first place 3 b's. Okay. Let's say we had 1 b here, 1 b here, 1 b here, and 1 b here. Sorry. Yeah, okay. Okay. Now, how many R's do we have to place? We need to place 4 R's. So let's take 1 R here, 1 R here, and 1 R here. And we can also place 1 R here such that there is no more than one consecutive R. Okay. Now, what if this R was 5? If this R was 5, we'd actually place that R either here, or here, or here. Let's say we placed it here. Now we have two consecutive R's at max. Okay. Let's do this one more time. Let's say R was equal to 6. Then we need to add one more R. Now we cannot add one more R here because that would actually increase the consecutive R's by 1. So what we do is we put it here. Now if this R is 7, we again do the same thing. We place one more R here. If it's 8, we place one more R here. Now if it becomes 9, then again we have 4 sets of R and every set has 2 consecutive R's. So we take that extra R either at this place or at this place or here or here. So let's say we placed it here. And so on will go. So basically how we are doing this is, we first see what is the number of R, then we divide this by b plus 1. The reason for that is because we had 3 b's, so 1b, 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 and we had 4 places where we could place R's, so b plus 1. So for 9, this actually gives us 9 by 4, which is 2. Okay, now since this is 2, that means we first place 3 b's, place 2 R's everywhere. And now how many R's are we left with? We are actually left with what? 2 into 4, that is 8. So we are left with R would be actually become, this was 2, so 2 times b plus 1, which is 8. So R minus equals to, so new R will actually become 1. New R will become 1 and we can place that 1 R behind any b, either at this place or at this place or at this place or at this place. Okay, so in any of one of the sets we can place that extra R. Okay, so I'll quickly show you my code and hopefully this video is not lagging anymore. Okay, I'll show my code. So this is what you had to do. See, okay, so what I did was my n is equals to R upon b plus 1, which is actually the number of values we need in one set. Okay, then what I did was I multiplied this n by b plus 1 and that is the remaining number of R's I'll have. Okay, now what I do is I take j equals to 0, j less than 9, j plus plus, and I print all those. Okay, so what I do is I first print my first set. Okay, then what I do is I place my b and then I place my second set. But before that I just see if I have any number of remaining R's remaining. If I have, I place one more R. Okay, effectively what I'm doing is okay, so initially my R was 9, b was 3, so my n became 9 by 4, which is 2. Okay, and my new R became what? 2 into 4, which is 8, so 9 minus 8 basically. So my new R became 1. What I do is I first place n number of R's, so I place 2 R's. Okay, then I come into this loop, and in this loop I see, do I have any number of R's remaining? Since I had 1 R remaining, I place one more R, I make it 0, and then I place 1b, and then I place n number of R's. N is 2, so I place 2 R's. Then again I come on to this loop. Okay, I see my R is now equals to 0. Since my R is equals to 0, I cannot place any more R's. I place one more b, okay, and then I place 2 more R's. And then again the same thing, 1b, 2 more R's, and that's it. And that is all you had to do. Is this clear now? The code for problem A, is it clear? All right. Okay, I don't see any yes or no's. Okay, hopefully this is clear. Nice implementation for A. Thanks. Okay, cool. Okay, let's move to problem B now. Okay, so in problem B is bit flipping. So let's start that one. I don't really remember. Okay, I remember this question. Okay, cool. Okay, so you're given a binary string of length L. You have exactly k moves. In one move, you must select a single bit. The set of all bit except that bit will be flipped. Okay. So, okay, you need to output the lexicographically largest string that you can get after using all k moves. Also, output the number of times you'll select each bit. If there are multiple ways to do it, you may output any of them. So, you need to find the lexicographically largest string after applying k operations. Okay, that is what you have to do. Okay. Now a binary string A is lexicographically larger than a binary string B. Okay, that's just what lexicographically means. Okay, in the first position where A and B differ. Okay, cool. Okay, okay, I hopefully this will clear out. Okay, I won't really waste any time here. Okay, now for each test case output two lines. The first line should contain the lexicographical largest string you can obtain. The second line contains n integers f1 till fn, where fi is the number of times the ith bit is selected. The sum of all the integers must be equals to k. Okay, cool. So how do we do this? Okay, let's take which test case? Let's take the last test case. Okay, or let's see what happens. Okay, let's say we have some n. Okay, this is some binary values, some binary string, and let's say our k is even. If our k is even, okay, and if let's say we do one move at this position, so what will happen is, since we had what, four places, okay, okay, I have a green one. Okay, it's cool. Since I made one move here, what will happen is that this bit will remain the same and every other bit will be flipped. Okay, so let's say I had what? Now every other bit is flipped. Okay, now I have k minus one more move. Since I have k minus one more moves present, okay, what I have to do is, in every other move, what will happen to this bit? This bit will keep on changing, and since this is odd, this bit, if this was 1, this will become 0. If it was 0, this will become 1. Okay, so basically what is happening is, if k is even, okay, and if you select an index once, it flips in the end. Okay, so basically let's say we had 1 only as the string and k was 6. Okay, and we had some more values. Okay, in the first operation we did the first operation on any other value, so this one remained the same. Okay, then in the next 5 operations, this one kept on changing. First it became 0, then 1, then 0, then 1, and then again 0. So in the end, this one was changed to 0. Okay, so basically if k is even and if you did one operation on any index, then in the end the value will be flipped. Okay, is it clear to everyone? Okay, then the same thing. Okay, same thing for the other one also. Okay, okay, what happens if k is odd? What happens if k is odd? If my k is odd, okay, and if I select an index once, okay, let's say I had 1 and then some values, okay, and my k was 7. If my k was 7 in the very first, if my k was 7 in the very first operation, if I do this operation, okay, this won't change, this will remain 1 only, and then we have some values. Okay, now we are left with k minus 1 operation, that means 6 operations, and in 6 operations this will keep on flipping, but we know that it will become 0 1 0 1 0 and 1, so this one will remain 1 only. So basically if k is odd and if we do an operation on any one index, then that value remains the same. It remains the same. Okay, okay, now let's take a what? Let's take the last test case. We have what? Our n is equals to 6, our k is equals to 12. Okay, and we have 0 0 1 1 1 and 0. Okay, now we know that our k is even. Since our k is even, we know that if we select any one index, it will flip. Okay, we need to make this lexicographically largest. In order to make this lexicographically largest, we need to change some zeros to 1. And since we know if we make one move on any one index, it will flip. Okay, so we make one move here, one move here, and one move here. After this, okay, we are done with 3 operations. 3 operations are done. And our final string at the moment is 1 1 1 1 1 and 1. Okay, because we did 3 operations, we don't care how many operations are still left. We just know that if k is even and if we make one move on any one index, the resulting string will have the index, the value as flipped. So we did one move for this one move for this one, and one move for this one, and all the 3 zeros were flipped. We know this is the lexicographically largest value, but since we did 3 operations only, we are still left with 9 operations. Now, in order to keep this lexicographically largest, we'll actually take all the remaining operations and place them for the last value. This will either become 0 or it will either remain 1. In any case, this will be the largest value. Let's try this for another test case. Let's see this for what? Let's say k was equals to, okay, let's take the test case above this one. Okay. In this, we have n is equals to 6, k is equals to 11. Okay. And the string is 1 0 1 1 0 0. Now, we know that k is odd. If k is odd, we know that if we select any one index once, it remains the same. We need to make this string lexicographically largest. In order to make this string lexicographically largest, we need to replace zeros to ones. Okay, but we know that if we select any index once, it remains the same. So if we make one operation on this, it will remain the same. Okay. Instead, what we need to do is, we need to flip these. And to flip these, we need to make sure that we never change these values. Okay, so what we do is, we actually flip these ones. In 3 operations, okay, we make one operation on this, one operation on this, one operation on this. The string remains the same. Okay, after those, we know that the string will become 1 1 1 1 1 1. The reason for that is because we did one operation here, one operation here, one operation here. We know that at the end of all the operations, this 0, this 0, this 0 will be flipped because we didn't do any operation on these 3 indexes. Okay. Or yeah, if we select an index once, it remains the same. So we selected this once, so that this remains the same. We selected this index one, so that it remains the same. We selected this index one, so that it remains the same. Rest of the indexes, we didn't do anything. And we assume that after remaining operations, okay, after remaining what? 8 operations, these will be flipped and they will become 1 1 1. Now, whatever operations you are left with, do all the operations on the last string. Okay, and that is what you have to do. I'll explain this once more. Okay, I'll explain this for which one? Again, for the previous test case only. Should I take that? I want to consider an even test case. Okay, let's take the second test case. My n is 6, my k is 4, okay, and my string is 1 0 0 1 1. Now my k is even. If my k is even, I know that if I select any one index once, it will flip. I need to flip this 0, and this 0. So I'll make 3 operations, and my string will become 1 1 1 1 1. Okay. Now I'm left with one operation, so I'll do that one operation on the last index. Okay. The reason I do that is because I need to have the lexicographically largest string. And in order to have that, I need to make sure that all the other values remain the same and only my last bit changes. Okay. So I do that one more operation on the last bit, and my remaining, my final string becomes this. Okay. All right. Should I explain this for odd again? Okay, I'll do for odd also. If my n is equals to 6, my k is equals to 11, and my string is 1 0 1 1 0 0. Okay. I know my k is odd. So I know if I don't select, okay, if I select an index once, it will remain the same. But if I don't select any index once, it will flip. So let's say that at k is equals to 11, first I do make what? I make 3 operations, one for this one for this one, and one for this one. Now I am left with what? 8 operations. And let's assume even after these 8 operations, okay, everybody, these zeros were flipped. So my final string becomes this. Okay, now I take all my rest of the operations and do on this one. Basically, what I'm doing is, first I make 3 moves. Okay, in those 3 moves, okay, I do one move here, one move here, one move here. I know after all my operations, since I've made one move here, one move here, one move here, this will remain one, this I don't know, this will remain one, this will remain one, this I don't know, this I don't. Okay, now I need to ensure that I don't select this index, don't select this index, and don't select this index. But I'm still left with 8 operations. So what I'll do is I won't touch this one, I won't touch this one, but I'll make all the remaining 8 operations on the last one. So this 0 will remain the same. This 0 will flip because I know if I don't select any index, it flips. So I make this one, I make this one, and then I make 8 more operations on this one, and this becomes 0. This is my answer. Okay, but since I had 3 operations here, so this was 1, so this will become 1 only. Okay, you don't really have to do like operations, you just have to find the count, and then in the end you can just see which one flips and which one doesn't. Okay, now I'll quickly show my code also. Okay, so this is the code. What I'm actually doing is I'm just scanning the complete string. Then I have 2 vectors, 0 and, okay, I don't have my screen. Okay, so this is the code. What I'm actually doing is first I scan my string, then I have vectors for 0 and 1. What I do is in the complete string, I check if my any index is equal to 0, I push that index into 0 vector, otherwise I push that into 1 vector. Then what I do is I see if my k is odd. Okay, now we know that if my k is odd and if I select any index once, it remains the same. Okay, which indexes do I want to remain the same? I need all my ones to remain the same. So what I do is for all my ones, I make one move there, because I need to make one operation there so that in the end they all will remain the same. Okay, so I made one operation on all the ones, and I just made count plus plus that this is the number of operations I'm already done with. And same for the else case. If it is even, if my k was even, I know that if I select any index, it flips. So I'll take all my zeros, make one operation on those zeros so that they flip into 1. So I do the same thing here also. Now I see how many operations I'm left with. I'm left with k minus count operations. I take all those operations, do on the last index, because I don't really care about the index, because I need the largest lexicographical value, and my last index can be anything, but I cannot touch any of the previous values. After doing that, my answer vector, this answer will contain all the values, like how many flips I had to do for every index. Then I just calculate my final string. What I do is, so again the same thing only. If my k is even, I know if my k is even, okay, and if I select any index, then it flips. Answer I percentage 2 means that I'm doing odd number of operations. Odd number of operations means I'm selecting that index, because if it's 3, answer is equals to 3, then first and second operation will cancel each other, but I'll have the third operation. Okay, so if it's odd, if I'm selecting an index, it will flip. So I flip that index. And same for the even case. For the odd case, I know that if I touch any index, it will remain the same. Okay, so basically to make it flip, I need to ensure that I don't touch that index, so that has to be odd. Is this clear to everyone? Is this code clear to everyone? A little complex, I would say. Okay, 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 I think this is clear to everyone now. I don't see many likes to the stream. I only have 27 likes and I have 48 people watching. Can everyone please like the stream so that it reaches a wider audience? And I think we can move forward to problem C now. Okay. Okay. Harshit says no. Okay. What part is not clear? Is the code not clear, or is the like logic not clear? I'm pretty sure like the logic is clear to everyone. Maybe some part of code is not clear. Okay. Okay. I think due to some lag, I'm not able to see the latest comments. So I think I'll move to problem C now. If you have any issue with the code, you can just go back into the stream and watch. Okay. Let's move on to last part of code. Okay. In the last part, actually, what I'm actually doing is, if my k is odd, I know that if my k is odd and I select any index once, it remains the same. Okay. So to flip, I need to ensure that it has even number of moves, because making an even number of moves is that I didn't select that index only. Okay. So if it's even, I flip the switch, I flip that value. And for even, if my k is even, which is this case, if my k is even, I know that if I select an index, it flips. So answer I percentage 2 is equals to 1. That means I'm selecting that index once and I flip it. I was only able to solve A and B. I'm so depressed. That's why I was not able to solve C. That's okay. That happens with everyone. Okay, cool. We'll move on to problem C now. Okay. C is actually like a very simple problem. I would say like even simpler than problem B. Okay. So let's move on to that problem now. Okay. You're an ambitious king who wants to be the emperor of the reals, but to do that, you must first become emperor of the integers. Consider a number axis. The capital of your empire is initially at 0. There are n unconquered kingdoms at position 0 till xn. You want to conquer all the other kingdoms. Okay, there are two actions available to you. You can change the location of a capital to any other conquered kingdom at a cost of a times. Okay, so basically, you can change the location of the capital. Okay, to change capital, your cost is a times c2 minus c1. Okay, and what? From the current capital, you can conquer. Okay, to conquer, your cost is actually b times c2 minus c1. Okay, note that you cannot place the capital at a place without a kingdom. In other words, at any point, your capital can only be at 0 or one of the other indexes. Also note that conquering a kingdom does not change the position of the capital. Okay, so I'll just explain the test case also so that it's clear to everyone. Let's take the second test case only. So what they're actually doing is, initially, should I like really explain this? Okay, I'll explain the input. Okay, so input is n is 5, a is 6, b is 3, and the array is 1, 5, 6, 21, 30. Okay, I don't think I need to explain the problem. Okay, so basically to change the capital, we need a cost of a times c2 minus c1, and to conquer, we need a cost of b times c2 minus c1. Okay, now how to do? Okay, I'll explain. So let's say this was the array, and you're starting from the 0th index. Okay, so 0th position, your cost at the moment is equals to 0. Now, in order to move to the very first city, you need to conquer this, because you cannot change capital before conquering, and your only conquered city is 0. So the very first operation has to be conquer. In order to conquer, your cost will be b times c2 minus c1, which is, what is b? B right now is 3. What is c2? C2 is 1, c1 is 0. 1 minus 0, which is 3. Now this is conquered and this is also conquered. Now you can either change the capital first, or you can conquer 5. Let's say we change the capital. If we change the capital, our cost will be plus a times a is 6. 6 times, okay, c2 minus c1. My c2 at the moment is 1, c1 is 0. So 1 minus 0, which is again 6. Now our capital is at this index. Let's say we conquer this one now. In order to conquer, our cost will be b times, which is 3, c2 minus c1, which is 5 minus 1, which is 12. Now this is also conquered. Let's say now we wanted to move our capital to this one. In order to move, our cost will be a times, which is 6 times 5 minus 1, which is 20. Now this is our capital, and let's say in the next turn we conquer this one. In order to conquer, the cost will be 6 times 6 minus 5, which is 6. Now this is conquered. In order to conquer the next one, let's say instead of changing the capital now, we conquer the next one. So it is what? 6 times 21 minus 5, because my C2 is 21. Okay, C2 is 21. This is conquered. C2 is 21. C1 is still 5. And this is what? 21 minus 5 is 16 into 6, 32, 64, 96. And then to conquer 30, we have 6 times 30 minus 5, which is what? 25 times 6, which is 150. And the sum of all these values is actually going to be, it was supposed to be what? Oh, this is, okay, did I do something wrong? To change capital, it is, you can change the location of capital to another by A, you can conquer, okay. Okay, B is 3, sorry, really sorry. This is opposite. This is 6, 3, 6, 3, and this is 3, 3, 3. Okay, and if you'll see, the sum of all these values is actually what? 171. Now, how to do this problem? Let's see. So, let's say these are all the cities, and you were initially at this place. This is conquered, this is conquered. The only option you have at the moment is conquering the next one, because your capital is at the last conquered city. So you conquer this one also. Now the next move can be, you can either conquer this one or move. So you can either conquer, okay, or you can move the capital to this, move capital. Okay, let's see what happens. Okay, in order to move capital, your cost will be what? A times C2 minus C1. Your cost is A times C2 minus C1. Okay, let's say instead of moving the capital, we kept us at here only. What was the total cost in difference which we had? Okay, so if our capital was this, let's say this is what? C1, C2, C3, C4, C5, C6. To conquer this one, it will be B times C3 minus C1. To conquer this one, it will be B times C4 minus C1. To conquer this one, okay, let's say we had 4 values. Okay. But if we had moved our capital here, okay, first cost of moving plus conquering these two, which is B times C3 minus C2 plus B times what? C4 minus C2. What if I subtract this value and this value? If I subtract these two values, what I will get is, okay, I'll just write what I'll get. What I will get is rest values that I am left with. Okay, the values, okay, so we had what? C1, C2, C3, C4. 2 cities were still left. So rest cities into B greater than equal to A. Okay, I'll explain this, like how I got this. So when you try subtracting, so this is to be subtracted by B times C3 minus C1 plus B times C4 minus C1. So this A times C2 minus C1 remains intact. B C3. So this C3 will be removed, this C3 will be removed, this C4 will be removed, this C4 will be removed. So we are left with what? Plus minus BC2 minus BC2 again. Okay, plus BC1 plus BC1. This is actually twice of B times what? C1, C2 minus C1. Yeah, minus twice of C2 minus C1. So we have A times C2 minus C1 minus twice of this should be greater than equal to 0. If this is the case, then only it is beneficial to move. Sorry, then only then this should be less than 0. If this is less than 0, that means it was better to move than to conquer. And again, solving this part, we will actually get a times c2 minus c1 should be less than 2 times b of c2 minus c1. This is common, this is common. So you get a should be less than 2 times b. What does this mean? This 2 was the number of cities that are still left to be conquered. The number of cities into b, if the product of these two is greater than a, then there is no point of moving. And that is all you have to check. So at any given point, whenever you are at any given point, let's say this is the complete array, and you have conquered till this one, and you are at this capital. Either you can make this as the capital, or you can conquer the rest of the value. If your a is less than 2b, okay, then it is beneficial to move your capital. Otherwise, it is beneficial to conquer the remaining value. I think this will become more clear if I show the code. So just look at the code. Okay. Okay, so this is the code. So what I'm actually doing is I scan the complete array. Okay. Then I say that I know that if I'm at index 0, I need to first conquer my very first city. So I conquered my very first city first. And then I say my capital at the moment is at index 0. Okay. Now I start from I equals to 2. Remember, I'm doing one based indexing. So now I can either conquer my city at index 2, or I can switch my capital to index 1. And to do that, this is the number of cities I'm left with. If the product of number of cities into B is greater than equals to A, then it is beneficial to move. Okay, same condition. If my A is less than 2B, if my A is less than equals to n minus I plus 1 into B, this is the rest number of cities I have, this is B. Okay, if this is true, okay, then I need to move. In order to move, my answer needs to be added by A times my current city or my last city which I conquered minus the capital, which is the capital. Okay, so this adds to the answer, and now I need to update my capital. So my capital becomes the last city I conquered, which is array of I minus 1. And now I need to conquer my next city, which is B times the current city minus capital. Okay, and this has to go on for all the cities, and in the end you can just print the answer. Okay, so I'm pretty sure like this is also clear to everyone now. Is this clear to everyone? C was nice. I did it for conquering one city and making it capital, and conquering other cities from the city. Did it for each city and took minimum. Yeah, you could do that minimum also. Otherwise, like I think this is a better approach to find the formula through which you can just check like either you need to move or make it as a capital. Okay. Instead of making a prefix array, suffix array, having all the counts and doing that. I applied binary search on index but got wrong answer. Okay. Okay. Okay, I think it's clear to everyone now, and we can move on to problem D. Okay, okay. आगे explain भैया please. आगे explain भैया. Okay, cool. Okay, let's move on to problem D now. D is a very creative problem. I understood the problem from people's submissions. I myself couldn't solve the problem. Code explain please. Okay, so basically what I'm actually doing is first I'm setting my answer equal to B into array I. This is nothing but the amount I need to conquer my very first city, because my array 0 is 0 only, so I didn't really subtract it. Okay, B is the factor that I need to multiply this, and this is the amount I need to conquer my very first city. Okay, now from city 2 I have two options. I can first move my move my capital to the last recent city I conquered, or I can just conquer my current city. In order to move my capital, this is the condition that I need to check, which we just derived. Okay, that if my n minus I plus 1, this is the remaining number of cities I'm left with. If my remaining number of city into B is greater than equals to A, okay, then it is beneficial for me to move my capital to my last conquered city. To move my conquered capital, to move my capital to the last conquered city, I need A times last conquered city minus capital. This is the cost of moving. Okay, and then I can just make my capital equals to area of I minus 1, which is my last conquered city. And then I need to conquer my current city, which is this is the cost for conquering my current city. Okay, and that is all you have to do. Okay, let's move on to problem D now. I think that's enough for problem C. If you're still unsure about this, just go a little backwards in the stream and just see. Okay, problem D now. Okay, I'll just erase this. I think C should have been swapped with A. No, I don't really think so. But yeah, if C would have been swapped with problem B, that would have been fine. At least I don't think like a rating of 1500 was okay for problem C. C was more like 1250. Okay, suppose you had an array A of n elements, each of which is 0 or 1. Again, a binary array. Let us define a function f of k which returns another array B, the result of sorting the first k elements of A in non-decreasing order. Okay, and then you just need to find the summation of all the values. Okay, so let's take the very first input only. We have 0, 1, 0, 1. Okay, for k equals to 1, this is the array. For k equals to 2, the array would become again the same only, because we need to select the first two elements, sort them. So this remains this only. Then for k equals to 3, we have 0, 0, 1, 1. The reason for that is because we have three values and we need to sort them, so it becomes 0, 0, 1, which is here. Now for k equals to 4, we have all the four values, we need to sort them. These are already sorted, so it remains 0, 0, 1. Now we need to find the sum of the complete array, which is 4, 2, 2, 0. Okay, and as you can see, the summation is 0, 2, 2, 4. Now you are given this array. You need to find the initial array from which you started with. Okay, and that is what the question asks. Okay, now okay, which test case should I take? I think I'll take this test case and explain. Okay, I'll quickly jump to the solution because we have already wasted a lot of time in the stream due to lag. So I'll just copy the solution. This is 0, 3, 4, 2, 3, 2, and 7. First, let's analyze this test case. Okay, to analyze, let's have the answer only. We have 0, 1, 1, 0, 0, 0, 1. Okay, for k equals to 0, this will, k equals to 1, this, or let's say 0 based indexing only. For k equals to 0, this will remain the same. For k equals to 1, it will be again same array only, because first two indexes are already sorted. Then for k equals to 2 also again same thing, 0, 1, 1, 0, 0, 0, 0. Then for k equals to 3, this will become 0, 0, 1, 1, 0, 0. Okay, this is 0, 1, 1, 1. For k equals to 4, this is 0, 0, 0, 1 and 1, and then again what? 0, 1. For k equals to 5, it will be 0, 0, 0, 0, 1, 1, 1. For k equals to 6, it will be 0, 0, 0, 0, 1, 1, 1. Summation of this is what? This is 7, this is 2, this is 3, this is 2, summation of this is 4, summation of this is 3. Okay, now let's see what is happening here. Okay, try to concentrate a little harder on this one because I'll quickly jump to the solution. Okay, now the very first value, which is non-zero in this array, will have its first. Okay, screen is half visible. Okay, so I think it is visible to you now. Oh, I just sorted the array according to case, and the summation of all these values is this one. Okay, now the very first non-zero value that you have in this array will have the very first one. Okay, so quickly we can say that the first value will be 0 because this is 0. But since the next value is 3, we can say that this was 1. Okay, and from this we can also say that at my third index, at k, my like k I equals to 3, at my I is equals to 3, I had my next 0. Because if you see this 0, from where did this 0 come? This 0 actually came from this one. So by the time I did not have any 0, I had ones only. My 0 came at the third index at I equals to 3. So at k equals to 3, I had my first 0 in this row, and then I had only zeros. That is why I had 3, I had 1 3 times. Because my first 0 after this index was at this place. Okay, so this was 1. Okay, and let's say I had made a queue, and in that queue I had pushed this 3. So this 3 came here. Then I come on to my next index, which is 4. And through this I know that my I of 3 will be 0. I'm not setting it 0 already, but I know that my I of 3 will be 0. Okay. Then when I come on to this index, which is I of 1, okay, I see from where did this 0 come? This 0 actually came from this 0. Okay, because this 0 came from this one, so this is the same 0 only. But then the next 0 came from the next 0 after this 0, which is this one. Okay, so since this is 4, this tells me that at k equals to 4, I had my first 0 in this line. So I made this 1. Okay, and I said that at k equals to 4, at I equals to 4, I'll again have a 0. Then I moved on to my next index. My next index said that I already know that this is a 0 because it is present in the queue. Okay, so this will be 0, I know. So I place a 0 here. Now, when will my next 1 come? Okay, or when will my next 0 after these 1 come? That will come after my index. Okay, I know that first I had some zeros. Now, how many ones will I have? The number of ones I will have will be equivalent to number of ones I had before, which is this a of I only. This a of I is keeping track of all the ones I had before, because this one is nothing but this one is nothing but this one. Okay, so I had 3 zeros, then 2 ones. This a of I told me how many ones I had before. My next 0 will come from this 0, which is actually my a of my index, which is I of 3. Okay, since I'm at I of 3, I know that before this I had all zeros. Okay, then at I equals to 3, I had my very first one, which was this one. Then I had my next one, which was this one, and the count of all my ones is already stored in a of I. So what I'll do is I'll say my a of I, which is this 2, plus the current index, which is I. After these many indexes, I will have my next 0, which is a of I is 2, my current I is 3, so 2 plus 3 is 5. So at k equals to 5, I'll have my next 0, which will be this 0, coming from an index 5. So I will push my 5 into this queue. I'll have removed this 3. Then I come on to my next index and say that since my queue had 4 at its front, I know this is 0. Since this is 0, okay, I know till I equals to 3 or I equals to 4 minus 1, okay, or before like I equals to 4, I will have zeros only. Then I will have ai number of ones. Okay, so I have 1, 2 and 3 ai number of ones, and then I will have my next 0. Okay, so which is ai, my ai is 3, my current index is what? 4. 4 plus 3 is 7. Since I had till this is I equals to 6 only, and this is out of the scope, I don't really need to set this value because it is out of the scope. I can just directly say that this is equals to 0. Okay, then I again move on to the next index. I pop this out. I see that my I is equals to this 5 only. That means this will be a 0. Now, since this is a 0, okay, I know that till k equals to 5 or I equals to 5, I will have all zeros. Then I will have ones. How many ones? Ai number of ones. Okay, so ai is what? 2. My I is 5, so this is 7 again. That means my next one will be at 7. Okay, but since I equals to 7 is out of the scope, okay, we can just remove that. Okay, like no need of inserting that. And this is also done. We pop this out. Now, since my queue is empty, I can just say this is 1. Is this clear to everyone? Or should I explain it again? Mahim says whiteboard not fully visible. I don't think so. My whiteboard is fully visible, ma'am. Okay, okay, cool. Okay. Shrey says good explanation. Thanks, Shrey. Okay. Again, Ikan says again. Okay, I'll just explain this once more. Okay. Should I do? Okay, I'll do this for the same example only so that it's more clear. Okay. So I'll just remove everything. It's a little difficult to understand, so it's okay if you are not able to understand it once. Okay. So my array was 0, 3, 4. I need more space here. So I have. Can you do it without knowing the initial sequence? Okay, let's do it without knowing the initial sequence. It's actually difficult to explain without knowing the initial sequence. I'll just, okay, let's do it without knowing the initial sequence. So we have 0, 3, 4, 2, 3, 2, 7. Okay. Since, okay, I have this queue. Since this queue has nothing, okay, and my value is 0, I'll say that I'll have a 0 here. Okay, again, since this queue has nothing, but this value is non-zero, I will say that I'll have a 1 here. And while inserting 1, I'll also insert 3 here. Okay, let me just write my indexes also. This is index 0, 1, 2, 3, 4, 5, 6. Okay, now, when I move on to the next index, which is I equals to 2, I see, is this I equals to this 3? No, it is not. Then I can say I'll have a 1 here. Okay, and I'll insert this value also. I'll insert 4 also again in the queue. Then I come on to next index, which is I equals to 3. I see this 3 is equals to my topmost element or bottommost element in the queue, which means this will be 0. I'll pop this element out and I'll add a of I plus I. My a of I is 2 and my I is 3. So that means 5. I need to insert 5. Okay, so I have 0 here. Let's come on to the next index, which is this one, I equals to 4. My bottommost element in the stack, in the queue, okay, is 4. Since I and bottommost element are same, I can say, okay, I can say I'll have a 0 here. And I need to add ai plus I in the stack. ai plus I is what? 3 plus what? 4, which is 7. And I need to remove this. Also, I need to see that this 7 is out of the scope. So there is no point of adding this in the queue. Then I again come on to my next index. Okay. This next index is what? 5. Okay. This 5 says that it is equal to this value. Since it is equal to this value, I'll have a 1 here. And I will insert what? I'll insert 5 plus 5 plus I is to 7. And 7 is not present here. 7 needs to be inserted, but since 7 is greater than the values, so I just pop this element and that's it. Now, since my queue is empty again, I'll insert a 0 here. Okay, I'll quickly go through this again. Okay, so what I'm doing is, I have this queue. Since I have nothing, I'll insert a 0 here. Next, since I have nothing, but my value is non-zero, I'll have a 1 here. And whenever I'm adding a 1, I'll add the value of the next possible value. So I have what? ai plus I. a of I plus I, which is 3 plus 1, which is 4. Okay, sorry. I don't need to add this value. Okay, I just need to add this value because it is a 1. So I need to add 3. Then I again come on to the next index. Since it is not equal to, index is not equal to 3, so I can just say 1 here and I can push 4 here. Then I come on to this index. I know that since my current index is equals to 3 only, okay, and this is 3, I can pop this out, say I have a 0 here, and then I need to add a of I plus I. A of I is 3, my I is 2, so I push 5. Okay, now when I'm at this index, okay, I already know that this is 0. We already know that. Okay, so we don't do anything. Okay, but we need to insert what? A of I plus I, which is 3. Sorry. Yeah, which is A of I is 3. Okay, last time it was 2 plus 3. Now it is 3 plus 2. Again 5. So I insert 5. Sorry, it is 3 plus 4. Index is 4. So I insert 7. But since the 7 is of no use, we don't do anything. Okay, so again we pop this out, and then the next element is 5. Since my current index is equals to 5, I can say I have a 1. Then again, like when I pop this out, this 7 is not equal to index, so a 0 here. What is the intuition behind this method? The intuition is what I told in the previously. Okay, when I draw all the values and then I show, like, first we have some zeros, then we have some ones, and then we have some zeros. Okay, so I'll quickly show the code. Where is the code? Okay, I myself didn't submit this, so I'll show you somebody else's code. Okay, so friend standing. So let's see this code. Okay, so this is exactly what this person is doing. Okay, just a second. I need to. Okay, so come on. The last two digits are 0 and 1. No, they are 1 and 0. Okay. 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 So this is the code. Okay. So basically, we are running a loop from from 0 to n. PZ is the queue. PZ is the queue that I had. If my size of queue is 0 and AI is equals to 0, then I just say my answer is equals to 0. Otherwise, if the size of it is 0, but AI is not equal to 0, then I come on to this one and I say that answer of I is equal to 1, and I need to push this value into the next one. So basically, my array was what? 0, 3, 4. What was the case? 0, 3, 4, 2, 3, 2, 7. 2, 3, 2, 7. For this, I had a 0. Okay. But the next time, my size of q was 0, but this value is non-zero. So I say I'll have a 1 here, and I need to push a of I in my vector, a of I in my q, which is 3. So I pushed 3 in my q. Then when I came on to the next index, which is this one, okay, I again saw that my size of q, okay, my size of q is non-zero. Okay, so this is not true, this is not true, but my I is also not equal to front because my I at the moment is 2. This is 2th index. So I run into this one and I say my answer is equals to 1, and I need to push a of I, which is 4. Then again I come, okay, I say my current I is 3, size of q is non-zero, so these two are false. Then I say my I is equals to the front of the q. That means this will be 0. I pop this value and then I insert a of I plus I. A of I is 2 and my I is 3, so I insert 5. Okay. Then coming on to the next index, which is this one, for 4th index, again see that I is equals to the front value. So I need to make this 0. And I need to insert a of I plus I. My a of I is 3 and my I is 4. So I insert 7. Okay. This is popped. Then I come on to next index. My I is equals to 5 and it is also equals to this value. Since both these are same, okay, Just a second. Yeah, I put a 1 here. Why am I getting a 5 here? It has to be a, yeah, it has to be a 1 here. Okay, so 1 here, and then I pop this element, and then I have a 7 here. Like 7 is of no use because I is 6 only here, so here's 0, and that's it. Okay, I hope everybody got like how to do this. A little complex. If you are still not able to understand, just go back when I made the complete grid, when I made all the iterations of the array, and then just try to understand like why we are doing this. Okay, and that's it. Okay, with this I'm gonna end the stream. Do like the stream if you liked it, and do make sure to subscribe to the channel also if you want me to make more such videos. And the next contest is on 19th, I think. So I'll see you all on 19th. Okay. Next contest is on 19th. Yes. So let's meet on 19th now.